Alright, we're going to go over briefly building construction, how it relates to the truck company. So a few things we're going to cover during this PowerPoint are the principles of building construction, how a fire reacts in various different types of building constructions, the hazards involved, and then just some simple terminology to help you understand the language when we're dealing with building construction. So there's 5 types of building construction. Type 1, your fire resistive construction. Type 2 is your non-combustible or limited combustible construction. Type 3 is your ordinary. Type 5, heavy timber, or type 4, heavy timber, and type 5 is wood frame construction. So your type 1, your fire resistive construction, in town, these are going to be your high-rise buildings that are newly constructed. It provides everything in the building will be some sort of fire resistive construction. There will be no wood in the structural members or the any of the frame of the building. Everything will be metal, concrete, steel, non-combustible components will be a part of this building. So the only real hazard is what the occupants bring into the building. Those are going to be your combustible members, will be the contents that each person brings in to the building: furniture, clothing, supplies, whatever the case may be. So with a type 1 construction building, it does allow time for the occupant and the firefighters to get into the building, get out of the building, combat the fire. Type 1 really helps with preventing the spread of fire horizontally or vertically. So type 2 construction is your non-combustible or limited combustible construction. It is similar in materials that are used in it for type 1 construction, but there's just a lower level of fire resistance on the type 2. It could be from a 3-hour to a 2-hour fire rating. It could be from a 2-hour to a 1-hour fire rating. Just things like that. They may use different materials within the building that will not withstand fire for extended periods of time. So type 2 construction, again, the primary hazards are still going to be the contents that the tenants or occupants bring into the building. Because we're using steel or metal in these buildings, we still have to remember that that does expand about 4.5 times when steel or metal is heated up. So these are things we need to consider when we have fires in compartments in these types of buildings. Just because it's made out of metal or concrete, it doesn't mean it's not going to fail or start to break down. So here's just your simple, just a sketch of your roof, flat roof. This is a good example of flat roof. You got your rafters and then you have your metal decking. So in larger buildings, warehouse buildings, or buildings where the attic space or the top floor isn't finished and the ceiling is open, you'll be able to see these, at least the rafters and the metal decking layer, if you get a chance to look up. So on top of the metal decking, you're going to have some sort of insulating panels for sound and heat / cold. You're going to have a vapor barrier and then some sort of covering. This could be anywhere from riverstone to rubber to metal to even a green roof, which is topsoil, mulch, and plants. Here's just a couple other photos of different layers of different types of roof construction on commercial buildings. You see there on the bottom right, you have the riverstone. So that's something you need to consider. You may not know it from the street, but when you get up there, it's something you may need to consider. We're going to need a shovel or something to get the riverstone out of the area that we need to vertically ventilate. So type 3 is your ordinary construction. This is what we're going to have downtown. They call it a taxpayer, which is business on the bottom on the first floor, and then you're going to have your residential living spaces on the upper floors. These are typically a non-combustible exterior and structural members. So the outside and the things that are holding the building up are going to be concrete, steel, metal, masonry, but the interior walls, the partitions are going to be made out of wood. Like I said, most of downtown is going to be this type of construction. So with type 3, because now you're using wood, different types of materials, you're going to have a greater chance for concealed spaces, which we all know gives you smoke, fire, heat spread rather quickly now. Makes it easier for that nasty stuff to move throughout the building. And then also the contents inside the building and the stuff that the tenants and occupants bring in is going to be combustible. So your type 4, your heavy timber, pole barns, some Amish buildings. We don't have a lot of heavy timber in town here, but they're going to be non-combustible or limited combustible exterior walls and structural members. So think back, it's just going to be like the type 2 construction exterior. And the interior structural members are made from laminated wood with no concealed spaces. So the laminated wood is multiple layers of wood glued together to make one large member. Anybody that's been in a home with a large LVL beam in the basement, or a big LVL beam as a header going across a long span in a larger open area, this is similar to that. It's multiple layers glued together, or it could be one solid piece of nominal timber. So some primary fire hazards in type 4 construction. You're going to have a ton of combustible contents in the building. Structural, non-structural members. There's going to be a lot of combustible materials. Because they're so big, they're so bulky, they're built to withstand the loads. They do remain stable for extended periods of time under fire, but they're not non-combustible. So they will get to a point where things will start to burn and break down. So most common, your type 5 construction, your wood frame, as most people call it. So everything in the building is made out of is made out of combustible materials. Wood, plywood, siding, shingles, plastics, everything is going to be combustible. So your single-family homes, apartment buildings, up to 5 floors can potentially be wood frame. So majority of them are going to be unprotected materials. You have ample amount of fire spread opportunities, interior and exterior. Windows, doors, these things will not be rated. And then obviously the contents as well as what the tenants and occupants bring into the building are going to be combustible. So everything that's within this building is going to be combustible, and this is where we see most of our fires and most of our significant fires. So some common materials used in construction. We've all seen them in town. We've all been to buildings where they've had this type of material: wood, masonry, cast iron, steel, reinforced concrete, drywall or gypsum board, and glass, fiberglass. So for wood, you can have load-bearing or non-load-bearing walls. Load-bearing is the load-bearing walls are transferring weight vertically throughout the building. So obviously if we remove one of these walls or a portion of these walls, something catastrophic could happen. So we need to really pay attention of what walls we're breaching through, things that we're cutting, to make sure we're not making the situation worse for us. So to go back to that, the 1 and 2, it just shows the standalone platform or may adjoin different structures as a party wall. So on the left, you may have just wood sitting on a wall, or you may have two walls or two boards coming together on that wall to create one continuous. So the way wood reacts in a fire, it comes down to the size of the lumber, whether it's a true nominal board or a sawn piece of wood, and the moisture content in the wood. There's a minimum moisture content for it, which is irrelevant, but the more moisture is in the wood, obviously the slower it's going to burn. So masonry, these could be brick, stone, concrete. In townhouses or older homes, row homes, they'll have a firewall that's built with concrete, and sometimes you'll see it'll extend past the roof line, separating each dwelling from each other. And they could be burying outside walls with brick or concrete. So because these things are allowed to be used in fire-resistant buildings, they can withstand higher temperatures than normal other materials, but you need to recognize the signs of when they're starting to break down. Like bricks, they rarely show loss, but they will start to crack, start to deteriorate, or they just will fail instantly. Stones and blocks, both will start to spall or crack. They usually maintain their strength, but then once that happens, once the spalling and cracking happens, you need to be aware that there could be a failure coming soon. So cast iron, it's found in older construction, used on veneer walls, exterior wall coverings. Masonry is generally in the area of the covering, so this would be your decorative outside items. So an example of that is rec hall. The bleacher supports and concession stands are cast iron. So that's really, I haven't seen much of this in town other than some decorative items. So it stands up well to fire. Cracking and shattering when we apply water after it being introduced to heat potentially could happen. And bolts, anchors that fasten the cast iron to the building can fail. I mean, we all know with attachment points that's going to be our weakest point on most everything, because you're putting a hole through something that maybe wasn't meant to have a hole. So they're just things you need to pay attention to. So steel, we see steel going up in town all the time on all these buildings. It's a good material to be used for structural members. So steel beams, like I said earlier, they elongate when they're heated. It's not necessarily equal elongation. It could be on one side, it could elongate 4 inches, and the other side nothing. One side 3 inches, the other side 1. So it's not a constant elongation. It's just know that because it is steel, it still has a threshold where it cannot withstand anymore. And once that steel elongates, it's not going to come back to its original size. And like the picture on the bottom right, if the steel is up against a brick wall that is a structural member, great. The steel beam will expand, and it will expand through the brick wall. So reinforced concrete uses, we see concrete throughout town, structural members, posts, columns, floors. So it's usually reinforced with some sort of steel or mesh. They could use other types of materials, rebar. and it allows that allows the concrete to have compressive strength along with tensile strength. So it's not just going to be just regular concrete. There's going to be some sort of material inside it to give it that strength. So like earlier, concrete will spall, will crack, and when that starts to happen, that means the concrete is losing strength and there potentially would be a failure under fire conditions. So gypsum board, drywall. So it has a high water content. We went back to the wood where we were talking about the moisture level in the wood. So we're going to use the gypsum for insulating a steel. Maybe they need to wrap something to make it more fire resistant and not wanting to have it exposed. So if you have a wood structural member, if you wrap it in gypsum, that will allow it to withstand more time in fire conditions. So it's a good heat resistant or fire retardant. There are multiple different types of gypsum out there. You're not going to know what type is what during an overhaul situation or a fire condition, but just know that there are multiple types and they can withstand different temperatures, different hose streams, and so on and so forth. So glass, fiberglass use and reactions. So glass is usually not in a structural capacity. Glass can be safety rated, but that is not structural. That's just preventing injury, sharp shards, or somebody falling through the glass. Used on windows and doors. But conventional glass, like your double hung windows, things like that in a residential home, they are not to prevent fire spread. They will fail under fire. Everybody's been to a fire that has seen windows fail. So your conventional windows in your homes will not prevent any fire, or will not prevent fire from getting through them. So fiberglass used for insulation purposes. The glass component is not a significant fuel, but the material used to bind the fiberglass may be. Fiberglass batt insulation usually will just sit there and smolder. The paper on the outside usually is what will burn and cause fire to travel to areas that it originally wasn't. So just some hazards associated with building construction. We need to know, as firefighters and as firefighters responding to different types of buildings, we need to recognize what type of building we're dealing with. Not get real specific on all the details of the building, but just know that, okay, we're going to have some time for this one because it's a type 1 building. It's meant to be fire resistant. Or there's a big difference between that and a single family home where time is of the essence. So that comes into your size up and communication. Communicate everything that you see about these buildings, conditions changing. You start to see these signs that we talked about with these materials. Relay that to the incident command and the rest of the crews to prevent further injury, or don't ignore these signs, because you picking that out may save a life. So additional critical issues, just recognize building conditions. Recognize the conditions that may contribute to fire spread. Recognize conditions that potentially could cause the building to fail. And like I said, let somebody know those conditions if they're changing rapidly. Let them know your findings. Because like I said, these things, a building can in a second just start falling apart. And if these signs weren't recognized by anybody, we're potentially going to have injured firefighters. So all your combustible furnishings and finishes, a lot of tapestry on walls, things that aren't supposed to be on the ceiling. This is a reason to not. This is why we don't want fires to spread across the ceilings. This is why we don't want things hung on the ceilings, because fires will spread across the ceiling faster than they normally would have. Be aware of your roof coverings. There's all sorts of roof coverings in town: wood, composite shingles, tile, slate, asphalt. You're going to have terracotta. You're going to have stone. So you need to recognize those from the ground. And if you're riding the roof seat, or you're an operator that gets assigned to the roof, you need to recognize that, okay, I need to take a different saw. Maybe I need to take a sledgehammer and hit some of the slate pieces off to gain access to the wood decking underneath to make my ventilation cut. So there's multiple different floor and ceiling coverings. Everybody now they potentially could be using materials on the floor that's the same on the ceiling. So just your normal drywall walls are becoming a thing of the past. Everybody's a DIYer and is using all sorts of materials to make their place look internet pretty. So building collapses, like I said, cracks, separations, things that don't look right to you, you're generally on the right track. If something doesn't look right, it's probably not right. If you have bricks falling off the building, stones falling out, mortar coming out, things appear to be leaning more so than normal, bows in the roof, you need to radio these things to command so they can let the interior crews know that they potentially have a catastrophic failure coming their way. So a couple other points: structural members that appear to be distorted. If you have the rods or stars like in the photo, they're just holding everything together. That's not saying that this is a bad building. They are meant to just hold everything together structurally. Any noises, unusual cracks or creaks, or anything out of the norm, you need to let somebody know that that something is happening, and we potentially need to get our firefighters out of the building. So the collapse zone, a good rule of thumb is 2 times the height of the building. You can go, if you can condense it to 1.5 times if you don't have the distance to go out, but a good rule of thumb, 2 times the height of the building is a good number to stay at. So roofing hazards, especially in these Type 5 construction buildings, there's a lot of gusset plates being used. Gusset plate is a pre-engineered piece of metal that the truss gets put together. All these little plates get pressed in place on these trusses, and then they get put up. There's no nails connecting any of them. They're just pressed in place. So these trusses could be 2x3, they could be 2x4s, not real big wood, and you have minutes before these things start to fail under fire conditions. So your floor joists, your engineered stuff, truss construction, you're going to have wooden I-beams, which are on the left picture, in the middle of the left picture. You're going to have laminated beams, which are also in that left picture. The I-beams obviously look like an eye. You're going to have truss construction for floor joists, engineered stairs. So the web joists in the middle there, a lot of times they'll be protected by, they'll be wrapped in drywall if they're exposed in a basement. So these are all things, that I-joist is not very thick. It's plywood in the middle with 2 probably 1x2s that are on each end, sandwiched on each end. So your bowstring trusses, this building's out off of North Atherton Street, so we do have these in town. There's just a lot of weight going across that long span, so these are things you just need to consider. And accessing that roof, obviously, there's no roof ladder going to be used because it's a continuous loop. So these potentially could be a dangerous situation, especially with the amount of weight that they're holding up. So during construction, there is an issue for fire spread because a lot of these safety features aren't in play yet when something happens. There's not going to be any smoke alarms, anything like that. So really weigh your options responding to a building that's under construction for a fire. Is it really worth what we're about to try to go save?